Okay, good afternoon, everyone. Today we go one step back and we talk about some concepts of big data and cloud computing. Since you had some hands-on experiences before, some of them makes a lot of sense for you. Some of them could be new. So more specifically, we talk about infrastructure as a service, platform as a service, and software as a service. So cloud computing could be very intuitive. It just means there is one or some linked computers that you load your data and your commands, and after computing your code, you get some results. So it should be very intuitive. So but why an organization do cloud computing? So let's say you're an organization and you want to decide either you want to do local instance of Hadoop, which means I think some we had difficulties. It's needs a lot of expertise and like how to install and implement on even one computer might be a challenge. But when you go to cloud computing, you ask another company to help you, and you should pay for that. So can anyone tell me how we can justify, is it good to have an in-house cloud computing service? You might remember also in the last class, in the business intelligence class, we even talked about Siemens and also Silveris, that they brought some data visualization capabilities for they had in-house, and also they acquired some outsource for the data visualization. So it could be here. So any volunteer can tell me how you can justify, is it to have an in-house big data computing or reaching outside cloud computing services?
Depends on the size of the organization.
Yes, that's a very good answer. So any other idea? So sometimes on top of that, just size matters. So you might be in a startup, which might be just like less than 20 people in your company, or you might have 100,000 people working in your company. So hiring somebody who handles Hadoop and Spark requires money. So if in a startup, let's say you have 10 people, so hiring one, it just means increasing at least 10% in your human resource cost. Versus maybe if you are in the organization with 20,000 employees, adding one more staff, maybe it's almost nothing. Another one, you are not sure about your business. I think I showed you a video about Shashank. So he was in a startup company and they are not sure how many customers do they have. So if they think, if they are pretty sure they have a promising business plan, maybe they can have IPO and like get money and apply for grants for their business. But who knows? Maybe they invest millions of dollars and at the end they cannot make that much of money. Instead of investing millions of dollars, maybe they can reach AWS from Amazon, and they try to see if their business is running or not. Let's say maybe after 6 months or 1 year, if they think the business plan is promising, now maybe they can think, okay, is it a good idea to have an in-house cloud in-house big data computing or reaching cloud computing services? Sometimes it's just a matter of efficiency. Some governmental agencies in the United States, they even ask Amazon to provide cloud computing for them because they are not that much efficient. So even if they invest and hire people, the cost is much more than asking Amazon to provide it for themselves. So breakpoint, future business plan, and there's so many other factors that may contribute. So you might heard of visualization, like VirtualBox. So in visualization, basically you make a virtual ecosystem. And on top of that virtual ecosystem, you make your experiments, or more specifically and more commonly, people use it for learning purposes. Because instead of dedicating hardware and taking care of hardware, maybe you can have just a virtual environment. Less people try your environment and make their experiments and learn by doing. Having said that, Horton Sandbox, what they did, so they installed Linux. On top of Linux, they installed the flavor of Hadoop. And they made it basically make it, they made it prepare for you to learn their instance. So they provide it for free, but you guys, maybe you learn them and you end up being a company that needs Hadoop, and maybe you can reach them and ask them to provide that for your future company. So although they might be free, but they have some future market. They are thinking that if people are convenient working with the environment, maybe in future they would reach them and ask them to provide for the institutions. Okay, so the main or primary type of visualization is hardware visualizations. So VirtualBox, you might remember when you wanted to make a instance for Horton Sandbox, you dedicate some hardware and some RAM. So those are virtual hardware and RAM and CPUs that you dedicated for your Horton Sandbox instance. Having said that, so if this is your PC, you dedicate some part of your PC, like and you might remember I told you if you should dedicate good amount of RAM for Horton Sandbox. So all of them comes from hardware visualization. So you dedicate, let's say, maybe some part of your CPU, memory, some connections, which actually we didn't care about at that time. So VirtualBox has a hypervisor, which is software that makes some virtual environment. So, for example, Horton Sandbox, they dedicate some hardware, virtual hardware, and they basically, on top of that hardware, it was Linux, and on top of Linux, it was Hadoop from Horton Sandbox. So the application was a Hadoop instance on top of a Linux, on top of a virtual environment. So hypervisor, so VirtualBox has a hypervisor that takes care of several instances. On top of Horton Sandbox instance, maybe you can even have an independent Linux installation or independent Windows installation. Having said that, so for the people who just have a Mac, maybe they can use VMware, which is another hypervisor, or VirtualBox. And on top of VirtualBox, maybe they can dedicate some hardware, some part of their hardware, and install Windows. So they need to probably pay for that. On top of Windows, maybe they can have Power BI. So you might remember in the previous class, some of you had issues with the Power BI. You couldn't have it on your Mac system, but with VirtualBox and Windows, you can have a virtual Power BI on top of virtual hardware that is hosted by your PC through VirtualBox. Any questions so far? I think pretty much so far you had this experiment, and I know we had a lot of difficulties with Hadoop here, and also we want to see the difficulty of MapReduce, which you might see that maybe it's better to incorporate Hadoop ecosystem and Hadoop software instead of just doing every MapReduce by yourself. There's another term, containerization. So basically, it's like, if I oversimplify it, it's like having several IDs running on your OS, and each ID or user is independent from the other user. Like, I think in your computer labs, you might see that. So every user can log in. In Clark, you cannot install anything, just we can copy and paste. But at least you can, I think your PC is easier, so you might have several users. Each user might, maybe you can give them some authorization to the users, and they install some software independent from each other. Okay, now let's talk about cloud deployment models. So these are the major deployment models: private, public, and hybrid. So private means you have a lot more control on the hardware, and you reach a company, ask them to dedicate a specific hardware. Even you can negotiate about the location of hardware, number of instances, and almost everything is suited for you. So, but you should pay more, obviously, because everything is just designed or tuned based on your specific needs. And you are not sharing your basically virtual hardware with any other users. And the one is a public cloud. So most of the free services are public cloud deployment model. Also, I think that AWS is also a good example of that. So with AWS, you can have either both public and private. So in the public, you share some hardware or software with several users. If it's free, you just share with everyone. You might have some paid version of public users. So every paid user can share a certain hardware and software with you. Have you ever worked with the cloud computing center or cluster? None of you. Okay, that's a public one. Later we will talk about Databricks. That's a public deployment of cloud services. Then, which I later talk with you, I asked you to run Databricks ahead of the class. Sometimes so many people logging together, so it doesn't let you to use that service because it's a public service and it's a free one. So everybody. So let's say if at your class, so many people in the US wants to learn and have the same class at the same time with you, maybe sometime you cannot even log in. The other one is hybrid. So in the hybrid, you can. This is more used for sometimes you want to work with the people's individual data, or you have some privacy concern. So for the part that you work with the people's personal data, maybe you have a private network or private cloud. Maybe for other parts that there is not that much of privacy issue, you share with other companies or other users. And all of these three is just based on the cost, privacy concern that you decide. So if you have a very good business, let's say, and you have good budget like DoD, Department of Defense, so they are working with the private companies and they have private clouds. In Databricks, we have public cloud. Some of healthcare companies, they have hybrid ones. So with the patient-specific data, They don't share with, anything with anyone, so they just have a private company who provide the cloud services for them. But there's other businesses they have that there's not that much of privacy concern, so they're using a shared pool of resources. Okay, now let's talk about models. So here, deployment model. Now we're talking about service models. Infrastructure as a service, platform as a service, software as a service. So let's say you decide about the deployment model, either private, public, or hybrid. Now you want to see what you want from that cloud services. So do you want having whole infrastructure and you build on top of that? Let's say you might reach Amazon and ask them to give you like 10 computers that let you to install something on top of that. So in that case, you're asking Amazon, okay, give me like 10 computers. I will need this amount of hardware and like RAM, memory, connections, protocols that you build on top of that. Sometimes you ask for a platform. Let's say, I think operating system could be categorized as platforms. Some people have different ideas. But again, in Amazon AWS, on top of your hardware, maybe you want a Windows platform or Linux platform that you want to install your Hadoop on top of that. And the last one is software as a service, like on top of your hardware platform, maybe you ask them Hadoop, Pig, or other softwares that works for you. So you just build on top of each other. The newer one, which is not that much of, it's a very common, but it's not that not the original. It's not coming from the original definition. It's data as a service. So you reach a company, ask some certain data. You might remember Facebook. So they ask users data. Some companies ask for the user data for the marketing purposes or just for winning the election. For the infrastructure as a service is the most complicated one because you're just building on top of that. So first you need to know how much hardware you want. Then you need to have a knowledge of the making a platform on top of the infrastructure you acquire, and then also you need knowledge of how manage a software on top of the platform that you build on top of infrastructure. So for infrastructure as a service, might be very efficient, but you need some more expertise. Yes?
So in the previous slide, under infrastructure as a service, an example was memory. So if we purchase like a certain space on, let's say, Apple Cloud or Google Cloud, does that count as infrastructure as a service?
Google Cloud? Like, I think you can count it as a software because in the Google Cloud, or let me think. It could be both platform and software, but more specifically, could be a software. So, platform is basically a group of technologies that let user to create some content. Facebook, Moodle, Amazon ER, which we work later on. These are examples of platforms. So maybe in Facebook, you can share some posts or some information with people. On Moodle, I can, or your TA could create some sections and grade the students if they have authentication. But by the way, sometimes the border between software as a service and platform as a service is very close. So sometimes maybe we can say Facebook could be both, or Moodle could be both. So, but keep in mind, let's consider Facebook as a platform that everyone works. Hopefully all of you know and work with the Facebook. So if you want to work with the Facebook, you don't need to take care of the hardware that Facebook is running on top of that. So you get rid of it. So that part is out of your control. Another company takes care of it, but you take care of the platform, which is Facebook. So there's a much less complexity. For the software as a service, the cloud service company provides hardware, platform. Let's say they even talking about Amazon AWS. So basically Amazon AWS, you can take care of every part. You can identify the software. The platform could be, maybe you can merge Linux and Hadoop as a platform. You can consider both, but Pig as a software. So maybe they just provide Pig or Spark, and you just handle the last part. These are some example of software providers like Amazon, Google Apps, Dropbox. I think your question here, which is Google, the drive could be like something similar to Dropbox. But with the Google services, you can create some content too, right? So it has some online Word or Excel that you can create the content. So you could use it as both, actually. Databricks, which is the last one, and we spent a good amount of bricks on it. It provides Spark as a software and is free. Since it's free, it's a public deployment of cloud services. And on their public cloud, you have Spark, or more specifically PiSpark, as a software as a service, or SaaS. So for your project, which is a data-driven or machine learning-based project, so you need to use PiSpark. If your number of groups is one is an individual project, you can just use Databricks. You just upload your code and like your data, and you run your project. For two or more than that, my expectation is more. So this is the last level, which is software as a service. You can just use Databricks. If just one people doing the project, two or more, you need to use at least another type of technology or another deployment. You might even have a local installation of PiSpark and run the same codes on two different instances, either like through Databricks local installation or even AWS. But if you do AWS, you should take care of everything from infrastructure, platform, and software. Any questions? Similar to, Google Cloud is a good example. Let's say you want to type some, even I think Google Labs, you can have some notebooks, which I worked a long time ago, I think a couple of years ago. So in Google Labs, basically you create Jupyter Notebook and you run the code. You don't need to take care of Python installation. You don't need to take care of the hardware behind of that, and you just upload your data and you code and run. Database is exactly like that. Or even if you haven't worked with the Google Labs, so even for Google Cloud, or basically what you have from Gmail, let's say if you want to create a Word document, you just make new, type your text, and maybe you can share your text with someone else. So you never take care of Word installation, the hardware behind of that. this is exactly what Databricks do. But let's look at a cool video about Databricks. Actually, they are hardcore Spark developers, so they know this Spark software much better than so many other people around the world. Okay, let me copy. Might this?
In the digital age, data is everywhere. We all leave a data footprint wherever we go online. But with so much data, it's sometimes tricky to get your head around how it's collected and why it's collected, given the vast quantities of it. That's where Databricks comes in, one of the market leaders when it comes to data services. But what is the story of Databricks, and how have they reached a $28 billion valuation? Here's how it happened. First of all, we have to answer the question, what is Databricks? Well, Databricks is a San Francisco headquartered data and AI company founded by Ali Ghodsi in 2013, who was one of the original creators of Apache Spark, Delta Lake, and MLflow. Built on a lakehouse architecture in the cloud, which combines the best elements of data lakes and data warehouses, delivering data management and performance typically found in data warehouses with the low-cost, flexible object stores offered by data lakes. They might seem like a boring business that deals with data, and they even suggest they handle the boring AI needs for their clients. But they're trusted by over 5,000 businesses around the world, some of which are huge institutions like Shell, HSBC, T-Mobile, Microsoft, and Amazon, among others, who rely on Databricks to help with data engineering, science, machine learning, and analytics to help data teams solve incredibly difficult problems. Essentially, Databricks helps clients store, clean, and visualize vast amounts of data from disparate sources. Some examples include finance firms analyzing satellite data to understand where to invest money. Or Shell even used Databricks to monitor sensor data from 200 million valves to predict ahead of time if any will break. There are limitless uses for the software. The business was started in 2013 by the team of engineers who launched Apache Spark from the University of California, Berkeley, alongside one of the computer science professors there, Dave Patterson. Apache Spark is described as a lightning-fast unified analytics engine for big data and machine learning, and it has quickly become the largest open-source community in big data, with over 1,000 contributors from 250 organizations. It's 100% open source, hosted at the vendor-independent Apache Software Foundation. Apache Spark therefore laid the foundation upon which Databricks was built. When they first set up, Ghodsi and the team estimated they might be able to sell their business one day for a few $100 million, far underestimating themselves. They were also often told that their idea wouldn't take off because people believed that the cloud wouldn't work, that you'd need an on-prem or on-premise solution, with some companies investing billions into data centers. But their bold stand, which included turning down $20 million to build an on-prem version of their software, has seen the company rise to become a giant today. They make their money through a model they call software as a service open source. They offer a free open source version of Databricks, but their software as a service offering has more features that would interest business clients like reliability, scalability, and availability, with everything being on the cloud. Whilst their free version saw them grow like a B2C company, Databricks really needed to target business customers who were more reluctant when it came to paying for the service. Why pay when you can get something great for free? So they had to take a step back and think, what can we remove from the free version that keeps it functional and useful? And what can we include in our paid version to make it good enough that people won't mind paying for it? And customers have now been paying for it freely. So much so that Databricks have surpassed annual recurring revenues of $425 million, which has attracted a lot of attention from investors, and have raised over $1 billion in hard cash, which values the business at over $28 billion, with investments from Franklin Templeton, Fidelity, CPPIB, BlackRock, Alphabet, and T. Rowe Price, among others. After an oversubscribed funding round, Gotzi suggested that he's always left some valuation on the table after each funding round because it's a long-term game after all. The goal for the business isn't just to get to IPO, but to be around for a long time in a gigantic market in which they've only just scratched the surface. The team is so ambitious that sometimes they're keen to abandon yesterday's work because today's innovative idea might be even more successful. It's seen them partner closely with Microsoft, which helps the tech giant pass lots of data quickly, and Databricks are now an industry leader when it comes to cloud-based data engineering, and yet few people have heard of them. Perhaps with IPO fever around the corner, the public will soon know who Databricks are and understand the importance of businesses.
Yeah, the remaining are mostly advertising that ask so for you to buy their stock. So they have I'm not sure how they are performing in the stock market, but in 2021 they had a public offering. So some people bought the stock. So as you saw, the founders are Spark developer actually. So they are behind of the main Spark project. So they know how to implement. They provide the reliable resources for you to run your project. Especially if you're just individual project, you don't have any colleagues to help you to take care of some part of it. So with Databricks, similar to Google Cloud, you just upload, run your code. Still, PiSpark has some differences with Python, but it's very subtle. If you're already good in Python, learning PiSpark should be very easy for you. Maybe in just a few sessions, you would be a PiSpark developer through Databricks. Any questions so far? See people over Zoom. Yeah, I don't see any question. Data as a service. So these are the major provider of cloud computing, Amazon AWS and Microsoft Azure, both of the big ones. Cloud computing engine, Google Cloud, IBM Cloud. The cool thing about Google, if you have a startup and you don't have money for the infrastructure, and also if you don't have even money for a public version of deployment or any, you don't afford that, you can apply for a grant and they give grant to your startup for you to run your project. So, but just consider the owners or the major owners of Google are billionaires, so they know how to make money out of your ideas. So you need to read all of their conditions to see is it a good idea to ask them for a grant and run your business or not. If people have almost no money and you cannot find other people to give you grants, could be a good idea. Okay, talking about Hadoop, similarly, similar to PiSpark, many cases you just need to manage your data. You maybe don't reach to PiSpark for analytics. You need to decide which kind of deployment first you know. So, hopefully next week or a week after that, so we learn how to use AWS public deployment, which is a free one. I would warn you again, so they will tell you it's free, but still they find some ways to charge you. And every semester they forgive the students, but I'm not sure if it happens for future. I think your TA got charged like $300, $400 last semester, but they didn't bill him, so they didn't pay us. And they forgave him, but I'm not sure it happens for you this semester. But anyway, you learn how to have a cloud installation of Hadoop. So in data space, we reach Amazon, we ask for some hardware and software sorry, for some hardware like hard drive, RAM, CPU, which is free. Then on top of that, so-called free, they're not actually free. So on top of that, you install Hadoop, you install Linux, and on top of Linux, you install Hadoop ecosystem. And even we do some PiSpark through that, but just keep in mind, this is the plan that we do in a few weeks. But I think some of you might have had a lot of challenges with the previous local installations or even virtual instance of the Hadoop. So I will, for now, I will talk more about Databricks, so you can have a good idea how to do your own project. Then when I see we have a good progress, I go to Amazon AWS and you see how we can have Hadoop over cloud. Okay, so on Amazon AWS, so we won't see any hardware part. You just, similar to local installation, the last part of local installation, you install Hadoop, Yarn, and we also have this Spark part. You can do similar things with Pig. Hive has some similarity with Pig. Both of them are for querying. So just for your case, I also recommend to later on, which again, I go back to that. So install Pig on top of AWS Hadoop. So we can have some kind of experiment. Can anyone remember what's the differences of Hadoop ecosystem? So you have some databases over Hadoop. What's the difference of those databases over Hadoop, and just some regular databases that you have in your organization or on your local system? A database could be even one table. So even one Excel page could be a database. What's the major difference? So one, they have different applications. So Hadoop is for very large data sets that you won't afford on your local instance. But let's say even your data set is very small. It's so small that you can have on your own local PC, which we had before. So in last few weeks, we had local installation of Hadoop, Spark, and Pig. But we worked with a very small data set because we want to have some experiments that is doable on a local instance. And you have seen those experiments are not efficient because without Hadoop or Pig, you can run them much faster. So they have different applications. But what's the differences of working with data in Hadoop, let's say SQL, or even Excel, one sheet of Excel? Operationally, in Hadoop, you just save and read. But in traditional, it's very interesting because they are less than 100 years ago, or maybe less than 50 years ago, but we call them traditional database services. In them, you can change the data. So if you never have worked with SQL, at least I'm pretty sure you worked with Excel, so you can go to a table and change a cell, right? You can do in SQL, but you cannot do it over Pig. So Pig and Hadoop in general is just basically there for just dumping all of your data somewhere and retrieve and reading them. So let's say you read your data set and you make a query, then you export your query to maybe Excel or SQL on your system, and maybe you run your own calculation or computation on top of the retrieved data. So Hadoop and traditional database systems on your organization could work together in the way that Hadoop takes care of new data. So you dump all of your internal data into your Hadoop ecosystem. Then maybe you can make a query and just send the data to traditional systems that they might read, change, and just make their separate reports. Work sequential or independent or parallel with each other. Okay, this is, I posted 2 assignments. This is one of your assignments. It's called, when should we buy Hadoop infrastructure or use Hadoop Cloud? Make a one paragraph or a couple of paragraphs should be enough. And you said, which one is better? Maybe you said both of them have different focus. That's fine. Just discuss about this question. Hello, everyone. Today we want to make a Databricks Community Edition account. For this purpose, in the Google search engine, just type Databricks Community Edition sign up. Then in the first page, you can find Databricks Community Edition login. Just click on it. So this is the page that you might see. I already have an account. Now I want to try to make a new account, so you can just follow me. In this page, I click on sign up. Here, I'm going to provide my information. So I'm using my other university account information, but you can just simply use Clark University information. But anyway, so for title, you can just put Mr. Mrs. And just simply you click on get a start for free. In this page, you can select a cloud provider, but we just want to stay with the community edition. So in the lower part, just click on get a start with community edition. So now I've must check my email address and then click on sign up and just working with this with my Databricks account. Having said that, I'm now in my other university account. So I click on the email that I just received. Here, I'm just clicking on this link. I need to provide a password. Just select a secure password. Now I'm within my dashboard. So this is a public cloud, and as you already saw, that it's shared with other people. So what I recommend, maybe 10 or 15 minutes before your class, go over compute section on the left, then select create cluster. You just pick an arbitrary name like class, and just let everything be in the default and create cluster. It might take a few minutes. Then please have it ready. So when we are in the class, you can follow me. Each year, Databricks company might have some modification in sign up and how to play with the notebooks. So just keep in mind, make yourself updated and just frequently check if everything is still in the way that you want. So if there's a little changes, maybe you need to just update some settings. As you see, near class is just loading. Sometimes if it gets to the solid green plate, it just means that you're running. So, or basically your cluster is running. Here it's just uploading or loadings here, sorry. So click on the refresh page, see if it's still loading. Yeah, might just takes might take just a few minutes. Sometimes maybe like it might take 5 or 10 minutes. But if you start before the class, hopefully when I start teaching, everything is already set up and you can easily follow me. After your work, is a good practice just terminate your cluster. But if you don't work with your cluster, Databricks automatically kills your cluster. So you don't have to terminate it or delete it, but might be a good practice, especially later when you work with Amazon AWS. It's definitely a good practice to just delete your cluster. Thank you very much.